Hey guys, welcome to the first lesson for this unit, and this one is going to be pretty simple. Hopefully, like we've already been doing this. So using formulas to solve problems. What is a formula? A formula is a mathematical equation that relates two or more variables representing real-world quantities. Rules and procedures in many occupations are expressed as formulas, and we've seen this in some of our examples already when we did our geometry unit and our trigonometry unit. Those are formulas that you would use in that kind of a trade. All right, so let's take a look at our example, and we're going to substitute into a formula. Pediatric nurses use Young's formula, C equals AG divided by G plus 12, to calculate a child's dose of medicine, C milligrams, when the adult dose A milligrams, and the child's age, G years, are known. Suppose the adult dose of a certain medication is 600 milligrams. Determine the corresponding dose for a 3-year-old child. When I'm doing these, I like to highlight the important information. So, for example, I'm going to highlight the 600 milligrams and the 3-year-old child. And then I like to also put the letter kind of beside it. So 3-year-old child, that's the child's age, G. So I'm going to put a G there so I remember that. G is 3. And 600 milligrams, that's the adult dose. So that is A. So I'm going to put that right there so I know what that is. And then all you have to do is substitute those values into the formula, and then we'll solve it using order of operations. So here we go. Here's the formula over G plus 12. So wherever I see A, I'm going to put 600, and wherever I see G, I'm going to put 3. So C equals A, which is 600, times G, which is 3, divided by G, 3 plus 12. And then we'll just solve it or calculate it. So 600 times 3 is 1800. So I calculate the top, and then I usually calculate the bottom, and then we'll divide. 3 plus 12 is 15. And then I'll do 1800 divided by 15, which is 120. So what does that actually tell us? That tells us that the dose for the 3-year-old should be 120 milligrams for the 3-year-old. Okay, easy peasy. Just make sure you substitute all the values in for the appropriate letters and that you are following order of operations. Let's move on to another example. So here we have another example. A landscaper wants to estimate the cost of fertilizing a triangular lawn with side lengths 150, 200, and 300. One bag of fertilizer costs $19.98. And covers an area of 900 meters squared. She uses Heron's formula to determine the area of the lawn. And here's Heron's formula right here. And we can easily do this by doing a couple different calculations, and then we'll estimate the cost of fertilizing the lawn. So the first thing, notice in the formula it has a bunch of S's. We don't know what S is, but we can calculate it. A, B, and C are each of the side lengths. So I'm going to calculate that first. So S is 150 plus 200 plus 300, and it's all divided by 2. So I'm going to add those up. Just 650 and divide by 2, which gives me 325. So I now know that what S is in terms of our formula. So now I can actually calculate A and figure out how big our area is. So A, I'm going to substitute everything in. S is the square root of S, which is 325. 325 minus 150 for A. 325 minus 200. And 325 minus 300. Now, don't be afraid to write everything out. I find writing everything out keeps it nice and neat and tidy. I'm going to clean it up though. 325, and I'm going to do all my subtractions. So 325 minus 150, 175, 325 minus 200, 125, and 325 minus 300 is 25. So then we'll multiply them all. It's going to be a big number. So 57,025. And then I'll take the square root of it to get A. Which gives me 238.8 if I round. And that is meters squared. All right, so we also know that 1 bag of fertilizer costs $19.98, covers an area of 900 meters squared. Since our area is less than 900 meters squared, we only need to buy 1 bag. So we only need 1 bag. And the nice thing about this is that bag is going to cover at least 3 for at least 3 treatments. If it was more than that, you would just take the area and divide it by 900 to find out how many bags you had, and then multiply it by the cost to find out the cost. But since we only need 1 bag, this one was super easy. All right, in some examples, you're going to have to do a little bit of converting. Like in this one, a landscaper uses a bucket with radius 18 centimeters, height 18 centimeters, to pour soil into a rectangular planter that measures 1 meter by 40 centimeters by 20 centimeters. The first thing I want to do is change everything so that it is in centimeters, because the bucket's in centimeters. And most of that planter is in centimeters. I'm going to change this 1 meter to 100 centimeters. Once everything's in the same unit, it makes it much, much easier, and then we can easily figure out how many buckets we need to fill the planter. So first things first, we're going to find out what's the volume of the planter. Then we're going to figure out the volume of the bucket. And then I'm going to find out how many buckets actually go into each one. So the planter is length times width times height, which is 100 by 40 by 20. So 8,000, super easy to figure out. And the bucket is a cylinder, so it is pi r squared times h. And r is 18 centimeters, so it's pi times 18 squared times a height of 18. And if we calculate that, we get pi times 324 times 18. Times pi, I get 18,321. That doesn't quite seem right. Hold on, guys. Because this is 80,000, I forgot a zero. Look at that. Okay, so now that we know how much the bucket holds and how much the planner holds, we're going to try to find out how many buckets actually go into those planners. So I'm going to take the planter volume and divide it by our bucket volume. $18,321, and I get 4.366. So I'm going to say approximately 4.5 buckets. See? Easy peasy. I'll also give you a cute little summary here so that you guys can kind of follow this. Organization is an important key to solving multiple step problems, especially ones like this that have a lot of different parts. The answers to these questions may be helpful in planning your solutions. What formulas or relationships can be used? What numerical information is given, and that's why I highlight all the numbers usually. What numerical information do you need to find or estimate? So figure out what is it actually need to find, and what units of measurements are used. Do you need to do any converting, like I had to do in the last example? These problem-solving strategies may also be helpful if you work backward to determine what information you need, work forward from the formulas and information that you're given. And it's also nice to make a checklist of variables and their values. That I do that sometimes, especially in financial math, which we'll see in the next unit. But that's always really helpful if you have a checklist and you have things matched up. Anyways, that's it for today's lesson. Do the practice, have fun with it, and I'll see you guys later.